What is going on, team? It is your friend Austin here with AP Space, and today we're going to develop a C++ CLR serial communication GUI. So let's get right to it. So here we have what the GUI looks like, and then we have our project up that is currently running the current code for the GUI. And we're going to start from scratch, but we're going to reference this project while we are making the GUI. So we're going to close out of there. We're going to go to Visual Studio. We're going to go to create a new project. We're going to type in C++, and then we're C++ CLR. We're going to select a CLR empty project.net framework. We're going to call this project Wheat GUI v3. We're going to put this in the Wheat GUI v3 folder. We can put the net framework as default, and then go to create. Create. Okay, so now we're in Visual Studio, and how we want to continue is we want to go to Project, Add New Item, Visual Studio C++, UI, Windows Form. Okay, so now we have this currently, and then what we want to continue to do is hover over Wheat GUI v3. We want to go to Properties. We want to go to Linker. We want to go to System. We want to go to Windows, Subsystem, Windows. Let's double check we set that correctly. So in Properties here, Linker, and System Windows, System Windows, that seems to be correct. And Wheat GUI v2 is what we're referencing. And then we want to go to Advanced. We go to Entry Point. We type in the word main, and then we click on Apply and OK. Now we have that accomplished, and what we want to do now is move this over, go to My Form C++. We are going to reference our other project, and then we paste this piece of code. And now we edit Wheat GUI v2 to Wheat GUI v3. And then we save our project. And now that we have the initial configuration, we're going to close out of project. And then we go back into where the project is stored. And we open the project back up. Now we can see our Windows form, the My Form GUI. And we want our GUI to look something like this. So we now go to Toolbox, we search for label, and then we place label 1, we place label 2, and we place label 3. We also want a text box here, and we also want another text box there. And then we need our buttons now. So go to the toolbox and we type in button, button, and then we place 4 buttons, all like so. And we somewhat organize our labels here. And if we want to customize any of the labels, we can click on the label. Let's click on that again. Okay, so we're clicked in the label, right? And we want to call this Sweet GUI V3. Enter. We modify the font to bold and 18 and OK. We GUI V3. We go to label 2. We type inputs into label 2 and we click enter. We go to label 3. We go to output and enter. And then go to button 1. And the text on button 1 is going to be transmit 1 for one of our button outputs. So this is an output. And button 2 is going to be transmit 2. To enter, we are not seeing the rest of that because our button is not big enough, so we'll expand those. Button 3, we'll expand here. Button 3, we type in receive. Button 3, enter. And button 4 is our COM port. And this is actually a really good feature that this is actually how you select a COM port not in this area. So we're going to make the GUI to where you can actually type in the COM port name in the purple section and then also type in a custom string and then transmit through the blue button. More on that later, but the COM port will be named like so. We'll click on there. What we are going to do here is make the GUI look nice. So we're going to make the GUI yellow. We are going to make the text box blue. That blue. The transmit 1 button blue. Make the transmit 2 button green. Make the receive button purple. Choose that purple. And the COM port button purple. And then we'll go to receive. And we'll make the receive button pink. There we go. Okay. Now we want to edit our font on the input. We go to bold, 14 font. Okay. We go to output. We go to bold, 14. Okay. So now we have our everything color coded correctly. And you'll see why everything is color coded once we test our UART communication to the GUI. Okay, so the buttons are about where they need to be. What we do now is we click on button 1, and that puts that there, or moves the code over. We click on button 2, and click on button 3, and then we click on button 4. Okay, so now what we want to do is go to myform.h, because we put everything we needed in the myform C++ file, and then in the button 1 code, we copy and paste that over there. And that is essentially outputting a string from the transmit 1 button to the Photon 1 board. That is a custom string. Serial port 1 is not defined, and we currently have an error. We can fix that really quick. We go to Toolbox, we go to serial port, drag that into there. So this is very important as well. Baud rate is 115200. COM1, we can just keep that as is. We'll save our project. We'll go back to myform.h. Button 1 is all done. And then where are we going next? What we want here is button 2. Code will go there. The button 3 code needs to get copy and pasted over as well. Then we copy and paste over the final button. Array RX0 is not defined because we need to declare the global that is up here. So we'll copy and paste that there. We now have we'll copy and paste this over just so you're aware of a helpful comment if you want to see what this does essentially. Okay, so we currently are all correct as of right now. Let's see if our GUI works. Hey, very cool. Okay. Well, what do we want to do first? I guess we'll receive. Oh, COM port is closed. Okay, so that's why. I got my mouse plugged in. We'll plug in our. There you go. So what we have plugged in currently is this guy. So we're essentially plugging in a photon to this and then going to the laptop is what is happening. Okay, so that's plugged in. That's why that was there. This time around, we'll go type in COM4. We'll verify on our device manager where our COM port is. The serial port is on COM4, so we type in COM4. We click on COM port, and effectively what we did there is opened the COM port basically. So we essentially typed in the string COM4 and all of this block of code open the COM port. So now the COM port is enabled, and this is extremely helpful because you can type in any COM port if the COM port changes, which is an important feature here. And then we click on receive. Hey, okay, so we sure did get the right data. And what is happening on the input is we are receiving AP space 1 in decimal. And what we want to verify here is if that is correct. So we'll look at our ASCII table, right? And then 65 is capital A. So A, 80 is P, 83 is S, 80 is P, 65 is A, and you get the point from there. So essentially we're sending AP space 1 from the microcontroller, the photon 1, and the microcontroller that's on the photon 1 over to the laptop. So that's essentially receiving data to the laptop, right? And that was all from the previous video. That was done with C programming and QIDE and CubeMX, but it's the same UART interrupt software that's a receive transmit software as well. So we're using the software from the previous video to test the GUI, essentially, slightly modified. And now what we want to test is if we type in AP space 1 and then click transmit, the output says AP space 1. Did AP space 1 make it to the microcontroller? Hold on. Probably might have to recompile here. Okay, so let's resend what we just sent over. So we'll, this is the receive array. We'll retransmit AP space 1 and that did not work. Why did that not work? We plugged in. We are plugged in. Hey, there we go. Okay. So, So the reason why that was is because we needed to wake up the interrupt actually. So that wasn't anything wrong with the GUI. That was with this software actually. Since we restarted the code, we where was that? That's essentially because we needed to wake up the interrupt software before the interrupt software can receive in this loop essentially. So let's try something else here. Let's try transmitting photon 1. Hey, there we go. Photon 1, check that out. AP space photon 1. Uh, Photon 4, transmit. Hey, hey, check that out. Whoa. So we're essentially just sending data, and we can basically type in whatever string of data we want, and we can transmit data to the microcontroller, and then the microcontroller can transmit the data to wherever else essentially. Um, Now, this is also a good feature as well, I think, is that uh, transmit 2 transmits something that's hard coded. And this is kind of interesting with what the GUI does is that if you hard code it, it displays the output as just 1, 2, 3, 4, 5, 6, 7, 8. And effectively, where we coded that was in button 2. And we just hard coded with this line just an unsigned character pointer array 1 tx, and we just sent 1 to 8 essentially. And then that's all the buttons. We essentially reviewed and tested all the buttons, and we verified that it worked here. The one instance of the waking up the microcontroller essentially is that you have to send the data, and then once the UART interrupt wakes up essentially, then it can receive the data. So after the initial interrupt wake up, we were able to transmit the data just fine. So that is a note there essentially. So one last step here, once we have verified our serial communication GUI with a microcontroller to verify and with our IO labels to verify, we can close out of there. We can go to release. We can go to build. And then we can go to weak GUI v3, x64, release weak GUI v3. And then this is essentially the executable. So if you're making a product or something that needs to go on a custom single board computer or anything like that, you can essentially make the executable here. You can type in a custom COM port. If the COM port changes on the purple text label and on the blue text label, you can type in a string, click the button, and transmit whatever is in this text box. This button transmits something that's hard coded, so you could set a reset string here, and then this button receives data from the microcontroller to the laptop. So this is the input, this is the output, this is the output, this is initializing the COM port, and then this is just the label title. Or this is what we named the GUI, right? It's called Wheat GUI v3. So that concludes how we make the GUI. And one last note is on my website, I included Wheat GUI or the Wheat GUI v2 software that is the Visual Studio software. Everything we just posted here in Visual Studio, and then all of the software that we used in the Cube MX to initialize the pins, and then also the Keel IDE software, and also so the Keel IDE project and the Cube MX project is in here, and then the Visual Studio portion and the GUI executable is in here, which is quite helpful. And this is free, so this doesn't ask for a credit card or anything. And one last note, very important note actually. This is not going to work if the baud rate isn't set to 115200 bits per second, and the TX pin active level inversion has to be enabled, and the RX pin active level inversion has to be enabled as well for that to work. And then you have to configure the pins here. And then if this is confusing to you, reference the previous video. And we're using a Photon 1 going through an RS-232 to USB converter to the laptop. And then we are effectively interfacing with this GUI here, and then we also generated an executable. Hopefully this is helpful for you guys, and you guys all have a wonderful day.